All right, we're going to go ahead and get started here. Go ahead and pause now if you need to. Make sure that you have all of your flippies set up on the correct pages, your I can statement written down, and your table of contents. Great, now we'll go ahead and take a minute to try the Do Now problem on your own, and then we'll go through it together. Okay, so when I look at this problem, I see that we have two different volume measurements given as well as one pressure measurement, and we're being asked to find another pressure measurement. So the equation that has all of these variables is Boyle's law. So we have P1 V1 equal to P2 V2. And we're being asked to find P2, so I'm going to go ahead and divide both sides by V2 and get P2 is equal to P1 V1 divided by V2. And then if you go ahead and plug your numbers in, that gives us 1.5 times 5.6 and then divide that by 4.8. And if you go ahead and do that in the calculator, we end up with 1.75 atmospheres. Great. So we're starting a new unit here on solutions and solubility, and this video is going to take you through the notes for that first set of flippies. Now the first thing that we need are three definitions here. We know that, or we can say that solutions are homogeneous mixtures between a solute and a solvent. A definition of a homogeneous mixture is particles of the mixture are evenly distributed throughout. So if you picture something like ocean water where the salt is thoroughly mixed in throughout the water, that's an example of a homogeneous mixture. Now, any kind of mixture is made up of two components, the solute and the solvent. Now, the solute is the substance that's present in the smaller quantity, and that's usually some sort of solid that's dissolving in a liquid. The solvent is the substance that is present in the larger quantity, and that's usually the substance that's the liquid form. Oftentimes it's water, but we can use other materials as solvents. Now we'll go ahead and take a minute to check yourself here. I'd like you to circle all of the models below that represent homogeneous mixtures and create a particle model that represents a solution of water, sugar, and Kool-Aid. All right, let's go through this, remembering that homogeneous mixtures are evenly distributed throughout. And our first particle model here, it looks like there's one kind of material on the bottom of the mixture and the water molecules are above it, so this is not homogeneous. The second one looks like they are evenly spread out. The third one, again, not evenly mixed, so it's not homogeneous. This last one, we have a nice uniform mixture. So number 2 and number 4 are homogeneous mixtures. Now here I'm going to use red to represent the Kool-Aid powder, and I probably have not a whole lot, but some amount of Kool-Aid dissolved throughout the beaker. Now I'll use blue to represent the water, and there's probably going to be a lot more water than there is Kool-Aid. So I'm going to show that the water is the solvent. We have many, many water particles present. Keep drawing these in here. So you see that water is the solvent. It's present in a much larger quantity. Kool-Aid is one solute that's present, and we'll use green to represent the sugar. And sugar is another solute. There isn't very much of it, but if you have a nice tasty glass of Kool-Aid, there's going to be some sugar dissolved in there as well. Notice that this is a homogeneous mixture. I'm trying to draw it spread out fairly evenly. All right, go ahead and check yourself again, making sure that you know which is the solute and which is the solvent in the following three mixtures. All right, so for our first one, salt is the solute and water is the solvent. And we know this because water is the liquid and there's a lot more water than there is salt in any kind of saltwater solution. Another example is carbon dioxide in soda water. Again, carbon dioxide is present in the lesser quantity, so that's the solute, and the water is the solvent that's dissolving the gas in this case. And lastly, we have Nestle Quick. It's a milkshake mix, and that is dissolving in milk. So Quick is the solute, and the milk is the solvent in this case. Now we have some more definitions. If you flip the page, we have two different kinds of substances relating to solubility. The first is substances that are able to dissolve in water, and those are said to be soluble, while substances that are not able to dissolve in water are insoluble. So go ahead and take a minute, write it down. Which of the following four substances are soluble or insoluble in water? So we all know that sand will not dissolve in water. If you go to the ocean, there's lots of sand and it doesn't get all swept away. So sand is insoluble. Salt, on the other hand, dissolves in the water quite easily. So that is a good example of a soluble substance. Oil and water, again, don't mix at all. So that is said to be insoluble. But you can dissolve lots of sugar in your water. So sugar is soluble. Now, we have lots of different kinds of solutions, and we want to be able to describe how strong or weak they are. So we use concentration, which is defined to be a measure of the ratio between the solute and the solvent in the solution. So if we increase the amount of solute, then we increase the concentration. This might be the difference between something that is just a tiny bit salty versus ocean water that's really, really briny. The ocean water is much more concentrated. And we can increase that concentration by adding more solute, for example, adding more salt to your cup of water, or we could increase the concentration by decreasing the amount of solvent. So if we have a lot of salt and just a little bit of water, that's an example of a concentrated solution. Now we have some more vocab here. We describe solutions with a large amount of solute as being concentrated, or solutions that only have a little bit of solute and are mostly solvent, mostly water or some other kind of liquid. Those are said to be dilute. And lastly, we have one more check here. Go ahead and draw particle models to represent concentrated versus dilute solutions. Alright, so I'm going to use blue again to represent my solvent molecules. And in a concentrated solution, there is less solvent than there is in the dilute solution. So over here, I'll draw, say, 5 or 6 solvent particles. Over here, it's mostly solvent. We'll draw in maybe 8 or 10 of these solvent pieces. Good. And now I'll use yellow to represent my solute. This is the substance that's present in the lesser quantity. So there's going to be less solute than solvent. So we'll say maybe 4 or 5 solute molecules in the concentrated solution, but maybe only 3 over here. So we notice that both of these solutions have the same volume. They're taking up the same amount of space in the beaker. But the one on the left has a lot more of those yellow solvent particles than the one on the right does. And this is a good example of the difference between concentrated and dilute. Now we're going to go ahead and stop there for today. Next, you can get ready to work on solubility lab, and we're going to talk about different things that we can do to make a substance dissolve more or less easily.